Hi there, and welcome to our 17th episode in our Pharmacy Calculations practice series. Now, this question reads that an Amoxil suspension package label states to add 47 milliliters of water to provide 80 milliliters of a 250 milligram per 5 ml suspension. How much water would be needed to admix a 125 milligram per 5 ml suspension? Now, this doesn't look like it's a difficult question, but this is one of the harder calculation questions that I've seen in different practice and certainly requires multiple steps in order to solve. So I'll say up front, if you're going to see a calculation question on the pharmacy technician certification exam, and usually you're going to see, somewhere up to 10 questions or so, this is going to be one of the more difficult ones, so don't get too concerned. But first thing we need to consider is the fact that this is a suspension powder that's being admixed with the addition of water. And that powder itself contributes some of that volume for that final suspension. So when you have 80 mLs of a suspension that results after you added 47 milliliters of water, at some point we're going to need to factor in the difference between those two, which is 33 milliliters. So that's how much volume the powder itself is contributing. Now we're going to come back and use this information here in a minute. Now, we need to figure out how much water to add to this powder to wind up with 125 milligram per 5 ml suspension. When we add 47 milliliters of water to the powder, we get 80 milliliters of 250 milligram per 5 ml suspension. Now, I'd probably start with trying to figure out how much total milligrams is in this bottle. And we can do that by setting up a proportion. And remember, when we do this, we always put what we're solving for in the numerator on the right-hand side. So we need to figure out how many milligrams are in this 80 ml suspension that's made in that first example, when the known ratio is 250 milligrams to 5 mLs. So on the left, we put our known ratio with the units in the same spot. So we need to put milligrams up top. So 250 milligrams over 5 ml. And now we can solve this by taking that left-hand side and solving it. So 250 milligrams divided by 5 ml, and then you cross multiply to the denominator on the right. So times 80 milliliters. When you do it this way, the milliliters cancel out, and we're going to be left with 4,000 milligrams. So that's the total weight, I guess, of this Amoxil suspension powder. So if we want to get from 4,000 milligrams in this bottle to a concentration of 125 milligrams per 5 ml, we can set up another proportion to figure out what's the total volume we're going to need to add or have essentially in 4,000 milligrams to be equivalent to this concentration. So we're solving for volume, so XMLs per 4,000 milligrams with our known ratio on the left. And it's 125 milligrams per 5 ml, but we keep the units in the same position, so we're going to put that 5 ml in the numerator and 125 milligrams in the denominator. And again, we would solve this by taking 5 divided by 125 cross multiplied by 4,000. So it's 5 divided by 125 times 4,000. And X is going to equal 160 milliliters. So that's going to be the total volume at this concentration, but we need to figure out how much of that is going to be water that we add to that suspension package. And this is where we need to go back to what we calculated at the beginning, that 33 milliliters of that volume is the powder itself. So we simply take that 160 milliliters, subtract the volume of the powder, and this is going to be our answer. So 160 minus 33 is 127 milliliters. So that's how much water would be added to this suspension package to wind up with a concentration of 125 milligrams per 5 ml. Any questions whatsoever about this question, please contact us. And you can reach us on our Facebook page here at facebook.com/pharmacytechscholar, or email us at this email address, or simply find us on the web at pharmacytechscholar.com.